The PowerMaster 4 Series automated meter tester is a modern, lightweight, reference standard and current source combination that allows utilities to easily test meters under their ANSI test points. The 4 Series features an integrated zero insertion force universal socket that allows it to test all ANSI meter forms except 7S and 24S with no extra cabling or jumpers needed. The internal reference standard boasts 0.04% accuracy traceable to NIST, making it 5 times more accurate than most meters under test. The 4 Series can be ordered with either a 30 amp or 50 amp current source. The current source is not limited to only a few amplitudes and power factors, but is totally configurable for any current and any power factor you wish to test. In addition to watt-hour testing, the 4 Series allows testing for var-hour and VA-hour. It also has the ability to perform meter testing under forward or reverse energy flow and can test individual elements of the meter as well. For today's demonstration, we will be testing a 9S 3-phase 4-wire Y meter under its ANSI test points of full load, power factor, and light load. The 4 Series will test using an available single-phase voltage between 100 and 530 volts. You can use the included auxiliary power adapter to utilize wall outlet voltage, or you can connect the alligator clips to the voltage on the metering site. To start the meter test, we simply need to place the meter into the universal meter socket and lock it in place. We then position the adjustable IR pulse detector over the meter pulse output. On the main screen, there are 2 options for testing the meter. The first option allows you to test the meter while saving the test data and other relevant site information, like site ID, customer name, address, etc. The second option allows you to test the meter by simply entering the meter serial number. For this demonstration, we will not be entering site data, so we will simply scroll to Test Meter, No Site, and press Enter. We then need to pick the correct form of meter we wish to test, in this case, a 9S. We can then choose the actual meter we are testing from the meter database, which includes the manufacturer, model, and accuracy class of the meter. We then enter the meter serial number, the KT of the meter, and choose our IR pickup version. Since we are using the integrated adjustable IR pulse detector for this test, we choose internal for this option. For testing electromechanical meters, we would be using a different detector that is simply attached to the 4 Series. We then hit F4 to continue. We then choose the specific test we wish to perform. For this test, we will be performing the ANSI 2.5 amp full load, power factor, light load test, which will run the full load test at 2.5 amps at unity power factor, then the power factor test at 2.5 amps at 0.5 power factor, and then lastly the light load test at 0.25 amps at unity power factor. The user can create their own test points and pulses per test to match their own utility standard. We hit F4 to continue. The 4 Series then performs a status check to make sure that the meter is seated correctly and safely into the socket, that the correct meter form is actually being tested, and then looks for meter pulses. We hit F4 to continue. The 4 Series will then begin the actual test of the meter. The 4 Series will stabilize at each test point before data is collected. For each test point, the 4 Series displays the voltage, the current, the power factor, the time that has elapsed during the test, the number of test pulses, and finally the percent registration of the meter under those test points. You can see that for this test, the meter was well within its accuracy specification on full load, power factor, and light load test points. So we can simply hit F4 to stop the test. The test data has now been saved in the database and can be easily shared throughout the utility. In just a few minutes, you have completed the ANSI meter test. If you have any questions about this demonstration, please let us know. Thank you for your time, and as always, be safe out there when you're testing.